Hello students, welcome to JCE Connect, subject groundwater and hydraulics. We have started with Darcy's law. So just for revision, the statement of Darcy's law, that is the velocity of flow through a porous media is directly proportional to the hydraulic gradient. That is the statement given by Darcy. Okay, that is the Darcy's law. So here the hydraulic gradient, that is difference in the head. Okay, this water level, there are two piezometers which are inserted in a tube, okay, wherein water is sent in and here water is coming out, okay, and in between there is a sand column and area taken as A, that is a cross section area, you can say, okay. And what this Darcy's law says is the velocity of flow through this porous media, that is sand is the porous media here in this. So here the velocity of flow through porous media is directly proportional to the hydraulic gradient, that is the difference in the head in the water level. That is the statement of Darcy's law. That is V is directly proportional to I, that is hydraulic gradient. Now we'll see the validity of Darcy's law in today's class. So the validity of Darcy's law, this law is valid if the flow through the soil is laminar. So in previous class I have told you what is laminar flow. So laminar flow is what? Wherein the water particles of the water, they follow a defined path. So water molecules, whatever present in the water, they will follow a defined path. They never intersect. That is called as the laminar flow. And turbulent flow is the irregular flow, wherein the water molecule will not travel in a defined path. They intersect. Okay, so that is the difference between laminar flow and turbulent flow. So what the Darcy's law is valid if the flow through the soil is laminar. So I told you what is laminar flow, wherein the water particles, they move in a defined path. So the flow of water through the soil, it depends upon the dimension of the particles. That is very important. So if the soil is fine grained, okay, if the soil is very fine grained, then the dimension of the interstices or the voids which are present in between the two particles, they are very small, and because of this reason the flow is necessarily laminar. So if the grains are very fine, okay, fine grain nature, then the flow through such the voids are very small, okay, because of the small size of the soil, and as a result the flow is laminar. They will flow in a straight path. Whereas if the soil is coarse grained, it is coarse grained, okay, coarse grained soil if it is present, then the flow is again laminar, because the pore spaces are still bigger. If the grains are bigger, even your pore spaces are bigger in size, and the flow is laminar in such coarse grained soil also. But what happens if the soil is very coarse? They are like boulders or gravels, okay, very big in size, then the flow may become turbulent, because there will be more obstructions, okay, so flow will be turbulent. The water particles, they will not move in a defined path, so they will intersect, okay. So that is what, if the grains are very coarse, then the flow becomes turbulent, and for turbulent flow Darcy's law is not valid. It is valid only for the flow if it is laminar. Then the flow through soil, that is if the flow is lamellar if the Reynolds number is less than unity. So if the Reynolds number is less than unity, that is 1, then only for this case the Darcy's law is valid. If Reynolds number, that is if it is more than 1, what happens? The Darcy's law is, if it is less than 1, then the Darcy's law is valid, and it does not depart, or it does not depart up to RE is equal to 10, okay, which is an upper limit of the validity of Darcy's law. So fortunately most of the natural underground flow, whatever is happening, so that flow occurs with Reynolds number that is less than 1. So Darcy's law is applicable in case of groundwater flow or groundwater. So here the Reynolds number should be less than unity, that is important. So for the flow in pipes, what happens, and other large sections, the Reynolds number which is expressed which expresses the dimensionless ratio of inertial to viscous forces, which serves as a criteria to distinguish between the lamellar and the turbulent flow. So what this Reynolds number does, it will help, or it will express the dimensional ratio of inertial to viscous forces, serves as a criteria to distinguish the lamellar flow and the turbulent flow. So Reynolds number, that is expressed as, there is a formula for this, NR is equal to, that is Reynolds number is equal to rho V capital D divided by mu, that is the formula of Reynolds number. So wherein what is rho? Rho is the density of the fluid. Here for Darcy's law the fluid is water, okay, and V is the velocity, D is the diameter. If you are taking study for a pipe, okay, then the diameter of the pipe. Then mu is the dynamic viscosity of the fluid. Here again the fluid is water, so dynamic viscosity of the water of the fluid is mu. Mu is the viscosity, dynamic viscosity. So this is the Reynolds number. Now for Darcy's law to be valid, the relationship between the velocity, that is V, and the hydraulic gradient, that is I, should be linear. So we have discussed the Darcy's law, which states that V is directly proportional to I, right, that is hydraulic gradient. So the relationship between the velocity and the hydraulic gradient, that should be linear. That is again the one more validity of Darcy's law. Then it is valid for, that is Darcy's law is valid for flow in clay, silt and fine grained sand. So this Darcy's law is valid for the flow, that is if the water is flowing in clay or silt and even the fine grained sand, then the Darcy's law is valid. But if the grain size is coarse, in coarse grained sand, gravels, boulders, they are bigger in size, okay, the flow may be turbulent, and because of this reason the Darcy's law may not be applicable. That depends upon the porosity and permeability of the medium through which the water is flowing. So in case of finer particles, the Darcy's law is valid, because in previous slide we have discussed how the grain size affects the flow of water. Next, in extremely fine grained soil, that is very fine soil such as colloidal clay, the interstices are the gaps or the voids which are present in between the particles, that is called as the interstices, they are very small, and the velocity is therefore again very small, and for such soils the Darcy's law may not be valid. So if the particles are very fine grained soil, extremely fine grained, then like colloidal clay is again very fine, then the interstices, that is these gaps in between, okay, in between the particles, those are very small, and the velocity therefore may be very small. And if it is the if the velocity is very small, then again in such soils the Darcy's law may not be valid. Then this Darcy's law cannot be applied where the hydraulic gradient is very steep, such as near the pumping wells or pumped wells, wherein the hydraulic gradient will be very steep, okay. The difference in the water level, that is hydraulic gradient, that will not be, if it is very steep, then Darcy's law is not valid. Then the turbulent flow cannot be found in rocks like basalts and limestone that contain large underground openings. So turbulent flow usually is not found in case of basalts and limestones. These are the two different rocks, okay, that contain large underground openings. Like basalts have cavities because it is a volcanic igneous rock, and limestone, as its composition is calcium carbonate, that is CaCO3, there are underground caves which are formed because of the dissolution of the rocks with the reaction with the water. So in such rocks they may contain large underground openings, and here the flow will be turbulent, okay, flow will not be turbulent. So Darcy's law is valid. Then we'll see what are the assumptions made for Darcy's law. So Darcy's law is a basic law which governs the flow through the porous media. So the following assumptions are made. The first is the soil is saturated. Saturated here, the meaning is it is completely filled with water. That is called as saturated. So soil should be saturated, means water is present, that is it is a aquifer, so which holds the water. So soil should be saturated, which contains water. Then the flow is considered as lamellar, as we discussed in the last slide. The flow should be lamellar. That is the one more assumption which is made in Darcy's law. Then the flow is steady and continuous. The flow is steady and continuous. Then the total cross-sectional area of the soil mass is considered. So for Darcy's law, the total cross-section area of the soil that is considered, and the temperature at the time of testing will be 27 degrees centigrade, because if it is less, what happened, the water will start freezing. So here we are considering about the flow of water. So the temperature at the time of testing should be 27 degrees centigrade. So these are all the assumptions of Darcy's law. The first one is soil is saturated, okay, then flow is lamellar, and the flow is steady and continuous, and total cross-sectional area of the soil mass is considered, and the temperature at the time of testing will be 27 degrees centigrade. So these are all the assumptions which are made during the Darcy's law. So here the question is very important. Write a note on Darcy's law and the assumptions as well as the validity of Darcy's law. These all the three concepts are very important. Then we'll discuss the two definitions, that is what is mean by apparent velocity and actual velocity. So here apparent velocity that is defined as the rate of discharge of water per unit of total cross sectional area of the soil, that is called as the apparent velocity. So apparent velocity is what? The rate of discharge of water per unit of the total cross sectional area A. So here you can write it as in the form of expression, that is V is equal to Q by A. Q is the discharge of the water per unit cross sectional area. So that is A. So V is equals to Q by A. So this is also called as discharge velocity, or this is also called as Darcy's flow velocity. So you can replace this as V is equal to Q is replaced by minus KAI, okay, from Darcy's law. So that velocity is called as apparent velocity. Then one more definition you must know, that is actual velocity. What is VA? VA is actual velocity. So this velocity is defined as, again, the rate of discharge of percolating water per unit cross section area of the voids perpendicular to the direction of the flow. So here the area of cross section of the voids and perpendicular to the direction of the flow, that is very, very important. So what, according to this definition, if you want to express this in formula, VA, that is actual velocity, is equal to Q, that is the discharge of the percolating water per unit cross sectional area of the voids. So here area of voids is important. So Q divided by AV. AV is area, cross sectional area of voids, and it is perpendicular to the direction of the flow. So here you can express this as V, okay, A divided by AV. A is AV. A you can write it as A divided by AV, that is perpendicular to the direction of the flow. So here actual velocity and the velocity area, that is cross sectional area of the voids, so we have written it as AV. And VA, same expression you can write it as, that is nothing but the porosity. A by AV is nothing but the porosity, so that is N. So V by N, actual velocity, you can define as VA is equal to V by N, that is velocity divided by porosity. Porosity is volume of voids to the total volume. This we know, right? In the previous definitions we have seen what is the porosity. N is equals to VV by V, that is the volume of voids divided by total volume. So here cross sectional area of voids we have considered, that is nothing but the volume of voids, okay, and because of this you can write it as V is equal to VA is equal to, that is actual velocity is V by N. So these definitions also they may ask in the exam, so they are important from exam point of view, apparent velocity and actual velocity. So Darcy's law is a very, very important concept in groundwater studies. So thank you.